My name is Sigfrido SCARPA. I come from the University of Rome La Sapienza, and I came to Hanover to meet my colleagues in a consortium called develage, which is a consortium, European consortium for research in development and aging of the central nervous system. And what happens is that actually it turned out that practically 50% of the genes are regulated epigenetically, which is a quite important phenomenon that we have been ignoring for a long time. We knew there were things going on and changing during development and growth and aging, but we didn't know how. And then we started to, this was something mostly developed in the 70s and 80s and on. We developed the studies on DNA methylation. We realized that the genes could be turned off by DNA methylation. And this is what happens in development. Consider that all the genes for growth and maturation of an individual have to express themselves up to a certain point. Then they have to be switched off. You cannot grow all your life like some animals do. We don't. And at a certain point, the genes have to be switched off. How does this happen? My impression when I started to work on DNA methylation was that, and being interested in neurodegenerative diseases, is to see what happens in aging. In aging could be that some of the genes, I'm referring especially to the genes expressed in the brain, some of the genes may be reactivated somehow, which could cause a pathology. That could be one of the main causes of pathology. There are a large variability because they may be expressed partially, and they should be expressed that much and not more. But by aging, they get expressed more. This is probably what happens in Alzheimer's disease. In Alzheimer's disease, is not a real disease. It's an alteration of metabolism, of certain metabolism, because there are genes that work too much, let's say, and they produce more beta amyloid, which is the basic protein that causes Alzheimer. Why? So we went to see if the genes involved in the production of beta amyloid could be controlled by epigenetic marks. What causes the disease is probably not the plaque itself, because it has been shown that even a 20 years old man or woman already have plaques. But what causes the disease is the newly formed amyloid protein that goes to form oligomers, and the oligomers, with a mechanism that still we don't fully understand, degenerate the neuron. We are talking about enzymes that cut a larger protein to form beta amyloid. They have two possibilities: either to form beta amyloid or to form catabolites that are safe. But then a misconception about beta amyloid, which has been the cause of several failures by the drug corporations is the idea that amyloid was just a dangerous molecule. Amyloid has a function. It's probably a transporter. But anyway, the amyloid has to be produced. When they tried to suppress amyloid through the immunotherapy vaccines, they caused disasters. People died. People doing these tests with the vaccines even died because the brain barrier has been destroyed somehow. We have to consider the amyloid a physiological molecule. It shouldn't be overproduced. And the epigenetic marks gives us the possibility to do that. Leave acetylcholine on active longer time in the brain. But then this remedy works for 1-2 years in people that is showing the first signs of Alzheimer's disease, and then after that is useless.